Hello students, today we will do Thermochemistry Question Part 4. So in this question series, we will practice question from 22 to 29 in which I will be dictating the question, and meanwhile you can start solving it, and then I will give you 10 seconds more to solve the question. So I would suggest you that I am reading the question very slowly, so just utilize that time to solve your question and plus that 10 seconds that I will provide you. So let us start our today's question session. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this slide deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Question number 22. If at 298 Kelvin the bond energies of CH, CC, C double bond C and HH bonds are 414, 347, 615 and 435 kilojoule per mole respectively, the value of enthalpy change for the reaction in which ethene is reacting with hydrogen to give us ethane at 298 Kelvin will be. Your options are A 250 kilojoule per mole, B minus 250 kilojoule per mole, C plus 125 kilojoule per mole, D 125 kilojoule per mole. So the hint for this question would be that the enthalpy of reaction can be written in terms of the bond energy. So once you are able to write that thing, then the question will be very simple to solve. So your 10 seconds to solve this question starts now. Okay, so time is up. Let us move to the solution part. So what was being given? So basically the CH bond enthalpy means the energy that is required to break this bond, then C single bond C, then C double bond C and HH bond. Four types of bond energies are given and those are given in kilojoule per mole. Now you have to find the enthalpy of reaction for this reaction, which is simply hydrogenation of the ethene molecule to ethane. Now how we'll do it? For those who have solved, the correct answer is D. So as I have told you that if you are able to write the enthalpy of reaction in terms of the bond energies, then you are good to go to solve the question. So I am writing the same thing here. So del H, that is enthalpy of reaction, can be written in terms of. So we are taking positive of the reactants, right? Why are we taking this? So in general, product minus reactant is done. So you must have seen this multiple times. But we are taking reactants first of all, because in this whole reaction, what is happening? That bonds are being broken among this thing and along this thing, and bonds are being formed for the product side. Now this energy is given already in terms of the bond breaking, and we are doing the same thing. So we have taken the positive sign, whereas we are forming bond on the product side. Okay, we are forming bond on the product side. Therefore, we will take a negative sign because the given energies of this say CH3 CH, that means the CC or HH or CH are all for bond breaking and not bond forming, right? And this is bond forming. So we will take the negative of those, right, which are given. Now how many types of bond are there on the reactant side? So if you look on the reactant side, so this is the reactant side, right? So we have one CH, two CH and three CH and four CH bonds are there, two here and two here, and one double bond C, okay, here. Then we have one HH bond. Clear? Now moving on to the product side. So since on the product side we are not breaking the bond but making the bond, so we will take the sign negative of the given bond energies, as bond energies is for breaking the bond. So 6 CH bonds, okay, good, and one single CC bond. Now we will put all these values along with the equation that we have got. So that will give you your final answer. So 4 into 414 plus 615 plus 435 minus for the product. So that comes out to be minus 125 kilojoule per mole, which is your option D. So what is the main hint for this reaction, or main thing for the reaction, is that you should be able to write the enthalpy of reaction in terms of bond energies of reactants and products, and in this case you do reactant minus product and not product minus reactant. Once you do that, second thing you should remember that how many CH bonds are formed, how many C double bond C bonds are formed, how many of them are broken. You must know them, and then accordingly multiply with the stoichiometry, right? 6, 5, and all. Then you will get your answer, which is as minus 125 kilojoule per mole. Now this question is done. Now moving on to the next question. Question number 23. Given that the enthalpy of formation of N2O is 82 kilojoule per mole, bond energies of N triple bond N, N double bond N, O double bond N, and N double bond O are 946, 418, 498, and 607 kilojoule per mole respectively. The resonance energy of N2O is, so this is the thing that we have to find. We have to find the resonance energy. How will find it? So the hint will be that the resonance energy is the energy that is being extra supplied, because since delta H formation is given, and you can find the delta H formation using these values also. Okay, you know the thing that you will write the standard enthalpy, the standard equation for the formation of N2O using the standard states of each element, and then what you will do, you will just write the enthalpy of that reaction in terms of the bond energies, and then you can calculate your thing. But the problem here is that the value which you will calculate will be not equals to delta HF naught. Okay, delta HF naught, a value will be not equal to the value which you will find. Now that extra energy that you will see, that will be released, is nothing but your resonance energy. So just calculate both of this and you will just see the say difference, and that difference will be your answer. Clear? Okay, the options are minus 88 kilojoule per mole, B minus 66 kilojoule per mole, C minus 62 kilojoule per mole, and D minus 44 kilojoule per mole. So your time starts now. So your time is up. So let us move to the solution part. So the question is already explained. So that we will move to the solution part. Before that, the correct answer is A for those who have solved it. So this is the standard equation for formation of this N2O, which is N2 plus half O2 giving us N2O. Now, if you just break down this equation into much simpler form, in which you have given the bonds also. So we have N triple bond N, O double bond O, N double bond N, double bond O. So this is the thing. Now we know the formula delta H again, right, in terms of reactant minus products and not product minus reactant, because reactant bonds have been broken and the energy that is given is already for broken, but the product bond have been formed and the energies that are given are for the breaking of the bond. Therefore we take the negative sign against it. Clear? So writing the delta H for this reaction, how we'll write it? Let us see. So we have one triple bond on the reactant side, N triple bond N, and one and half mole of O double bond O. So therefore multiplied this by half. Then we have N double bond. So therefore N double bond, and then N O double bond. We will take a negative sign in between. Putting all these values, you will get 170 kilojoule per mole. Now, according to the ideal condition, this should be the delta H formation for the N2O. This is the ideal case, but the value that was found, which is the experimental value, this was found to be 82. Okay, this was found to be 82 and calculated value is 172. Now the difference between these two is nothing but our resonance energy or the extra stability that has been provided. Clear? So 170 amount of energy should be there, but due to the extra stability, that is of the difference between these two, and that will be equals to 88 kilojoules. So this much amount of energy is released due to the stabilization due to resonance. Okay, so that is again with a negative sign, and 88 will be your correct answer. Clear? Question is simple. So two things you should remember. First, this one, it is very obvious for the bond breaking and bond making, that reactant minus product should be done. Second thing, this thing, right, that your experimental value that you get will be smaller than the calculated value due to the extra resonance energy, and that energy you have to calculate. So sometimes question may be asked that what is the experimental value, and in that case your resonance energy may be given, or they can play with either of this. Okay, three terms are there, they can help you to calculate the two, and the rest, the third one, you have to calculate it by yourself. Okay, then you will use this formula, very easy formula to solve. and very easy to get right. So because resonance, what it does, resonance stabilizes the overall system by delocalization of charges, and that delocalization of charge lowers the energy of the compound which is released by the system, and hence with that energy release is written in terms of negative sign. Clear to you? Now moving on to the next question. Question number 24. Using the data provided, calculate the multiple bond energy of C triple bond C in C2H2. The energy is how much? So you have to calculate. Take the bond energy of CH as 350 kilojoule per mole, means to break one CH bond, and to do this reaction, energy is given, that is from carbon and H2 you are forming C2H2. Then to convert your solid carbon into gaseous carbon, and then to convert your H2 into 2 moles of hydrogen atom. All of these energies are given: 225 kilojoule per mole, 1410 kilojoule per mole, and 330 kilojoule per mole. Your options are A 1165 kilojoule per mole, B 837 kilojoule per mole, C 865 kilojoule per mole, and D 815 kilojoule per mole. Now what is the important hint in this question? So you have what you have to find? You have to find the multiple bond energy. That is what C triple bond C. So what you will do is you will use this equation. So you will write the enthalpy of reaction for this equation in terms of the bond energies, right? You will do this, and for those each thing is given. Okay, all of the values are given. So your 10 seconds to solve this question starts now. So your time is up. Let us move to the solution part. So this was your main equation. I said you have to use this equation, and the extra data is here and 1 is here. Then you can easily find this C triple bond C. So for those who have solved, the correct answer is D. So how we'll do it? So this is the equation that I have told to use. So they have just reversed the equation. You can take the main equation also, and at last you can reverse the value. You will get the answer. Next thing is, by using the given bond energies and enthalpies, we can write delta H is equals to minus 225 kilojoule per mole. Okay, so yeah, so when you will reverse it, this will give minus 225. So first thing what we are doing, we are converting solid into gaseous, and then we are using it, because in the main equation C gaseous is used. Then we are using the formation for the 2 moles of H2, because this is the bond energy for the dissociation bond energy. So if you just add equation 2, 3 and 4, then you will get your main equation, which is this. Okay, and upon calculating you will get a 1515 as your delta H. Now 1515 is delta H. This thing is given, right? This thing you need to calculate. So CH was already given. If you put these values here, then you will get your bond dissociation energy of C triple bond C. You got it, right? So easy to solve. Just you have to use the main equation accordingly, such that you are getting your things done more easier. Okay, moving on further. So that same thing is being done. So the bond dissociation energy of C triple bond C is found to be 815 kilojoule per mole. So this is your correct answer. Moving on to the next question. Question number 25. The standard enthalpy of formation of NH3 is minus 46 kilojoule per mole if the enthalpy of formation of H2 from its atom is minus 436 kilojoule per mole, and that of N2 is minus 712 kilojoule per mole. The average bond enthalpy of NH bond in NH3 is, your options are A minus 964 kilojoule per mole, B plus 352 kilojoule per mole, C 1056 kilojoule per mole, and D 1102 kilojoule per mole. So what will be the hint of this reaction? That again the enthalpy of formation of NH3 is given. You can write this enthalpy of formation in terms of bond energies, and for that your formation of H2 is also given from a 2H atom, and that of N2 is also given from the 2N atoms. So you will use these three, and to find the average bond enthalpy of NH, say NH, just calculate the overall formation of NH3 and just divide it by 3. That will give you the answer. So your 10 seconds to solve this question starts now. So your time is up. Let us see the answer. So I have already explained you the question. For those who have solved, the correct answer is B. So they have first written the standard enthalpy of formation of NH3. So with help of N2 and H2. So this thing is given. Now the bond enthalpy of NH is 46 kilojoule per mole. Positive sign is taken because we are supplying that energy, right? We are supplying that energy. So therefore, your 2H is going to H2, formation is given. Bond dissociation and that is the bond dissociation energy is given 436 because here we are forming the bond, but here we are breaking the bond. Similarly, for N2 formation is given. So again, we will take the bond dissociation opposite of that. Now for this, we can write in terms of reactants minus products. I said you earlier, right? That you will take reactant minus product whenever you are writing the enthalpy of reaction in terms of the bond energies because the reactants bond are been broken and the products bond are been formed. Clear? So that thing, substituting that thing 7, 12, 436, and you have to calculate this one while the overall enthalpy of formation is already given as minus 46 kilojoule per mole. So we will get this thing. But what we need is this value. Okay, average bond energy is to be found and not the overall NH3 formation is to be found. So calculating it further will give you 352 kilojoule per mole as your correct answer. Clear? Now moving on to the next question. The heat of combustion of benzoic acid is minus 2546 kilojoule per mole at 25 degrees Celsius and 1 atm. The delta U is, options are minus 1555.6 kilojoule per mole, minus 2044.7 kilojoule per mole, C minus 2544.676 kilojoule per mole, D minus 2868.66 kilojoule per mole. Now the hint of this question is, I think, very obvious, that you write the conversion of this and then you calculate delta U. Actually nothing more to be said in this question. So your 10 seconds to solve this question starts now. So let us see the solution part. I hope you have tried to solve it. So the benzoic acid combustion was given. So now for those who have solved, the correct answer is C. So this is the conversion. So what we are doing, we are combusting it and we are getting it 7 CO2 and 3H2. Now what is the value of delta Ng? 7.7 minus 7.5, that is 0.5. So this is 7 minus 7.5 because this is solid and this is liquid, so we don't consider this as we are calculating the number of change of gaseous molecules. Next thing, the delta H for this reaction was given, which was minus 2546 kilojoule per mole, and your delta Ng RT can be calculated using delta Ng value this, R this, and T this. So here we have taken kilojoule per mole rather than joule per mole because your answer should be in kilojoule per mole. So you need this thing. We rearrange the equation and we got this as minus 2544, that is minus 2544.76 kilojoule per mole as a correct answer. Moving on to the next question. Question number 27. Delta H combustion for ethane and ethine are given minus 341.1 and minus 310.0 kilocalorie respectively. What will be the ratio of calorific value of ethane and ethine respectively? Your options are A 1 is to 0.95, B 0.65 is to 2, C 0.95 is to 1, and D 0.02 is to 1. So your 10 seconds to solve this question starts now. Before that, let me give you a hint. So what you should know is the calorific value, that what amount of heat is required to raise the temperature and that all. And second thing, you should know that what is the combustion products and what is the balanced thermochemical equation for the combustion of ethane and ethine. If you know these three things, you can solve the question. Now your 10 seconds to solve this question starts now. So your time is up. Let us see the solution part. So the question was given that for the combustion of ethane and ethine, the values are given and you have to find the calorific value of ethane and ethine respectively. For those who have solved, the correct answer is C. So what is the calorific value of, that is the heat produced on burning 1 gram of fuel or the specific heat capacity. Simple, as simple as that. Now calorific value will be how much? It will be minus 341 by 30, that is 11.37 kilocalorie per gram, because this is given for per mole. So we have calculated for per gram by taking the molar mass. Next thing, for ethyne, again we are divided by the molar mass because we have removed 4 hydrogens, so that results in 26. Now divide it by 26 and you will get the calorific value, that is the heat produced per gram of ethyne, that is minus 11.92 kilocalorie per gram. Next thing, you have to find the ratio of calorific value. Very easy. You got this, you got this. Divide these two things, you will get as the 0.95 is to 1 as your answer. So in this way you will solve this question number 27. Moving on to the next question. Assertion reason type question is here. So assertion is combustion of all organic compound is an exothermic process. Reason, the enthalpies of all element in the standard state is 0. Options are assertions and reasons are both true. Assertion is the correct, reason is the correct explanation of the assertion. B, assertion and reason are both true, but reason is not the correct explanation of assertion. C, assertion is correct and reason is incorrect. D, both reason and assertion are incorrect. So your 10 seconds to solve this question starts now. So your time is up. Let us see the solution. For those who have solved, the correct answer is B. So in the combustion reaction, what happens? The sum of enthalpies of reactant is greater than the sum of enthalpies of product. So that is the basic criteria for an exothermic reaction. Therefore, combustion of all organic compounds is an exothermic. Also, enthalpies of all elements in the standard state is 0, and we know it very clearly. So therefore, assertion is true, but reason is not the correct explanation of the given assertion. Now next, moving on to the last question. Question number 29. Question number 29, statement 1. Statement 1 says that the enthalpy of formation of H2O liquid is greater than H2O gaseous. Statement 2. The enthalpy change of condensation reaction, that is H2O gaseous to H2O liquid, is negative. Statements options are statements 2 is true, 1 and 2 is true. Statement 2 is the correct explanation of 1. Statement 1 and 2 is true, but statement 2 is not the correct explanation of statement 1. Statement 1 is true, statement 2 is false. Both statements 1 and 2 are false. So your 10 seconds to solve this question starts now. Let us see how we can solve it. So the question was saying that the enthalpy of formation of liquid water is greater than the gaseous water, and the enthalpy of condensation is that is H2O is negative. That means heat is released. So for those the correct solved it, correct answer is A. So both statement 1 and 2 is correct, and statement 2 is the correct explanation of 1. So how is it so? So for that you have to understand the reason first of all, because during the condensation process what happens, the enthalpy change become negative. Okay, enthalpy change become negative. Why? Because during condensation the gaseous molecules that are present, they take energy from the environment and condense as a liquid. Clear? So for that thing, what happens, the energy of the say liquid state increases, and the energy of the gaseous state slows down, and that same thing in return in terms of this. So this is the this is a very good question. Just think of it in the way that I have told you, then you will get this concept easier, right? Now this was for today's question session. Thank you.